The human brain is the most complex object in the known universe. Composed of billions of neurons interconnected in intricate networks, it orchestrates every aspect of our being. From our thoughts and emotions to our movements and sensations, the brain is the conductor of our inner symphony. Over the past few decades, neuroscience has emerged as a powerful tool for unlocking these secrets. Using advanced imaging techniques, scientists are gaining unprecedented insights into the brain. Understanding the brain has profound implications for our health and well-being. Prepare to be amazed by the wonders of the brain, a universe within. The brain is built from billions of specialized cells called neurons. These remarkable cells are the fundamental units of the nervous system, responsible for transmitting information throughout the body. With their intricate shapes and remarkable abilities, neurons form the basis of our thoughts, feelings, and actions. Neurons communicate with each other through specialized junctions called synapses. At a synapse, an electrical signal traveling down a neuron is converted into a chemical signal, which is then transmitted to the next neuron. This intricate dance of electrical and chemical signaling allows neurons to form complex networks that underlie all brain functions. Imagine a vast network of roads connecting cities and towns. Neurons are like the roads, carrying information in the form of electrical impulses. Synapses are like the intersections where information is relayed from one neuron to another. The strength and efficiency of these connections determine how well information flows through the brain. Understanding the structure and function of neurons and synapses is crucial for comprehending how the brain processes information. By studying these building blocks of the mind, neuroscientists are unraveling the complexities of brain function and developing new treatments for neurological disorders. The brain is not a uniform mass of tissue, but is organized into distinct regions, each specialized for specific functions. Like a well-coordinated orchestra, different brain regions work together seamlessly to produce the symphony of our thoughts, emotions, and behaviors. At the base of the brain is the brainstem, responsible for vital functions such as breathing, heart rate, and sleep-wake cycles. Above the brainstem lies the cerebellum, which plays a crucial role in motor control, balance, and coordination. The cerebrum, the largest part of the brain, is responsible for higher-level cognitive functions such as language, memory, and decision-making. Within the cerebrum, the cortex is the outermost layer of gray matter, highly folded to increase its surface area. The cortex is divided into 4 lobes: frontal, parietal, temporal, and occipital. Each lobe is associated with specific functions, such as planning and decision-making, frontal lobe, processing sensory information, parietal lobe, language comprehension, temporal lobe, and visual processing, occipital lobe. Mapping the brain's landscape is an ongoing endeavor. By understanding the specialized functions of different brain regions, neuroscientists can better diagnose and treat neurological disorders, as well as develop new technologies that interact with the brain. Our senses provide us with a constant stream of information about the world around us. But how does the brain transform these raw sensory inputs into meaningful perceptions? The answer lies in the intricate neural pathways that process sensory information. Light enters our eyes, falls on the retina, and converts into electrical signals. These signals are transmitted to the visual cortex in the occipital lobe. The brain interprets these signals, extracting features like edges, shapes, and colors. Sound waves cause eardrum vibrations transmitted to the inner ear. Hair cells convert these vibrations into electrical signals for the auditory cortex. The auditory cortex processes these signals, allowing us to perceive sounds. The brain integrates all sensory information to create a unified perception of the world. Section 5. The plastic brain, adapting and changing throughout life. For many years, scientists believed that the brain was a fixed and unchanging organ after a certain age. However, we now know that the brain is remarkably plastic, meaning that it can change its structure and function throughout life in response to experience. This plasticity, also known as neuroplasticity, is essential for learning, memory, and recovery from injury. When we learn something new, connections between neurons strengthen or weaken, altering the flow of information through the brain. This process of synaptic plasticity is the basis of learning and memory. The brain's plasticity is not limited to childhood but continues throughout life. Even in adulthood, the brain can rewire itself, forming new connections and strengthening existing ones. This remarkable ability allows us to adapt to new situations, recover from injuries, and maintain cognitive function as we age. Understanding the mechanisms of neuroplasticity has profound implications for treating neurological disorders, enhancing learning and memory, and promoting healthy brain aging. Section 6. Unlocking the mysteries, recent discoveries in neuroscience. Neuroscience is a rapidly evolving field with new discoveries emerging all the time. From the identification of new brain cells to the development of brain-computer interfaces, recent advances in neuroscience are transforming our understanding of the brain and its capabilities. One groundbreaking discovery is the existence of neurogenesis, the process by which new neurons are generated in the adult brain. Previously, it was thought that neurogenesis ceased after birth. However, we now know that new neurons are continuously generated in certain brain regions, such as the hippocampus, which is involved in learning and memory. Another exciting area of research is the development of brain-computer interfaces, or BCIs. BCIs are devices that allow direct communication between the brain and external devices, such as computers or prosthetic limbs. By decoding brain signals, BCIs have the potential to restore lost function to people with paralysis or other disabilities. These are just a few examples of the many exciting discoveries being made in neuroscience. As we continue to unlock the mysteries of the brain, we can expect even more transformative breakthroughs in the years to come. Section 7. Neuroscience in Action, Real-World Applications. The insights gained from neuroscience are not limited to the laboratory but are being applied in various real-world settings, from medicine and technology to education and criminal justice. In medicine, neuroscience is playing a crucial role in developing new treatments for neurological disorders, such as Alzheimer's disease, Parkinson's disease, and stroke. By understanding the underlying mechanisms of these disorders, researchers are developing targeted therapies that aim to slow or reverse disease progression. Neuroscience is also revolutionizing the field of technology. Brain-computer interfaces, as mentioned earlier, have the potential to restore lost function to people with disabilities. Other neurotechnologies, such as brain stimulation techniques, are being explored as potential treatments for depression, anxiety, and other mental health conditions. In education, neuroscience is informing teaching practices and helping to develop more effective learning strategies. By understanding how the brain learns best, educators can create more engaging and effective learning environments. Even in the criminal justice system, neuroscience is being used to understand the neural basis of criminal behavior and to develop more effective rehabilitation programs. Section 8. Frontiers of the Mind, Current Research and Future Directions. With unanswered questions and exciting avenues for future research. As we delve deeper into the complexities of the brain, new frontiers of knowledge are constantly emerging. One area of intense research: the subjective experience of awareness. How does the brain give rise to consciousness? What are the neural correlates of conscious experience? These are some of the most profound and challenging questions facing neuroscience. Another frontier of research is the development of artificial intelligence, or AI, that mimics brain function. By studying the brain's computational principles, researchers are developing AI systems that can perform, such as image recognition, natural language processing, and even creative problem solving. The future of neuroscience is bright with promise. As we continue to unravel the mysteries of the brain, breakthroughs in our understanding of the human mind and our ability to treat neurological disorders, enhance human capabilities, and create advanced technologies. Section 9. The Future of Neuroscience. Unraveling the Enigma of the Brain. The journey into the brain is an ongoing adventure, full of wonder, discovery, and the promise of a future transformed by our understanding of the human mind. Neuroscience is not merely a scientific discipline, but a quest to comprehend the essence of what it means to be human. As we continue to unlock the secrets of the brain, we will gain profound insights into our thoughts, emotions, behaviors, and the very nature of consciousness itself. These insights will have far-reaching implications for every aspect of our lives, from how we educate our children and care for our elderly, to how we design our technologies and shape our future. The brain, once a mysterious black box, is gradually revealing its secrets. With each new discovery, we come closer to unraveling the enigma of the brain and unlocking the full potential of the human mind. The future of neuroscience is bright, filled with the promise of a world where we can harness the power of the brain to improve our lives and shape a better tomorrow.